Abstract algebra begins with a group. Groups are a general and powerful structure which encompasses a wide range of objects, the integers, polynomials, matrices, modular arithmetic, function, geometric transformations, and much more. Today, we'll talk about additive groups, which have a second operation, multiplication. We call this rings. A ring is a set of elements R with two operations, addition and multiplication. For both operations, the set is closed. This means if you add any element in R, you get another element in R. Similarly, if we multiply any element in R, you get a third element in R. For addition, the elements form an abelian group. For multiplication, there are fewer requirements. Like addition, multiplication has the associative property. We don't require multiplication to be commutative. We also don't require elements to have multiplicative inverses. There's still some debate on whether or not a ring should have an identity element 1 for multiplication. Because of this, you often hear people talk about a ring with identity. Thus, just means the ring has an element 1, and finally, these two operations are linked by the distributive properties. This is the official definition of a ring. There are additional names for rings, depending on how close it comes to being a group under multiplication. For instance, while all rings are abelian under addition, they are not required to be commutative under multiplication. The 2 by 2 matrices with real interest are a great example of a ring that's not commutative. But if a ring is commutative, we call it a commutative ring. Also, rings are not required to have multiplicative inverses. If a ring does have inverses under multiplication, then we call it a division ring. This is a very descriptive name because the presence of multiplicative inverses allows us to define division. Division rings may or may not be commutative. A classic example of a non-commutative division ring is the quaternions, a quirky four-dimensional analog to the complex number. But if a division ring is commutative, then we call it a field. So again, thank you for taking time to watch my video. I hope that you'll able to learn about ring. Thank you.